Hi everyone. In this problem, we have to find maximal square. Given an m cross n binary matrix filled with zeros and ones, we have to find the largest square containing only one and return its area. So here, right, we have to find the largest square which is containing only one. So let us take this example. Here, right, let us create a 4 cross 4 matrix, and from the problem, right, I hope you're able to understand there is only one way of solving it is through dynamic programming. Other one are going to give you timeout exception, so it is going to throw timeout. So let us create our matrix, although it's not quite clear, but still. So here, right, we are going to create a 4 cross 4 matrix, and we are going to fill it with the values of 1, whatever values you want to fill, right? 1 1 1, another one, 0 0 1 0 1 1 1 0 0 1 1 1, and let us create a 5 cross 4. So let me increase it, and here we're going to have 0 1 1 0. So here, right, you have to find the whatever the 4 cross 4 is possible, right? So here, if you look into it, right, so this is not possible, this entire thing. So then we are going to move from this one. So this would be another one. Again, we can go in this direction and keep on looping. And this is going to be a time compressibly massive, right? So it is not feasible for us to solve it in that way. So another way would be, right, one is like through linear way, right, searching of for all the possibilities, but that won't be very efficient. So let us create another one, and let me just draw it in a better way this time. So let me say, just please ignore the dog barking. It's like 4 a.m and I don't know why they're barking, so ignore it up. So let us create another matrix. It would be a little bit 3 cross 4. So here, right, the value would be 1 0 1 1. It would be having again 1 1 1 1 0 1 1 0. Okay, so for us to create a 4 cross 4 matrix, right, let's say this is going to be the element, right? So it can its neighbors, right? So its neighbor on the left hand side or the right hand side is needs to be 1. On the diagonal it needs to be 1, and on the bottom one needs to be 1. So here, right, when we are at 0, so I need to check, right, what are the its neighbor at this should be 1, not 0. What its value out here, and for a given matrix to work, right, so I can write the formula like uh, let's say dp of I and j for it to be correct, right? So first, right, this matrix or this cell needs to be 1, so I can say dp of I and j needs to be 1. And here one more thing to understand, right, here the values are given in string format, so you need to keep a track of it. So if it's 1, right, it would be 1 plus the minimum of left value r- down, and diagonal. Instead of left it should be right, and let's say left diagonal. So this would be the value. So here, right, it does not have any more values, right? And we have to create a condition, right? In case if it's going out of bounds, then we have to return 0. So here, right, we value would remain same. This one, the value will remain same, and same for the this one. And all the lower part, right, its values are going to remain the same. So what is going to change? So now you'd be moving into this index here, right? What is it? Is the value on the right is 1? It is 1. The value on the left diagonal, it is 1, and the value at the bottom is 1. So it would be 1 plus minimum of 1 1 1. So its value is going to get changed to 2. Similarly, right, we are going to add this index. So what will be the value on the right? It is 0, so it will remain same. If any one of them is 0, it's going to remain same. If it's 0, then we need not to check. Similarly, we can go in this index and this one. So all of them are going to remain same. And if we come at this position, so it is 1, but on the value onto the right cell, right, it's 0. So it is going to remain 1 as well. Now, right, whatever the decision tree or the dynamic matrix that we created, right? So here, from here, you have to find which value is the maximum. So here the value 2 is maximum. So if we get a value 2 maximum, then I can just say return, and let's say max value. And one thing to understand, right, if we're giving 2, right, so whenever it's written as 2, right, it would be 2 multiplied by 2, because we are just giving the number. So it's always 2 multiplied by 2. So to give it a square shape, so it is going to return 4, and that would be the output. So now, right, here you just got a basic understanding how the things are going to work. I think once you jump to the Python solution, things are going to get clearer. And if I look in the time complexity, it will be big O of m cross n, and we are going to have a cache to store so that the repeated computation does not happen, and we are able to store the values. So that's the idea. Let us jump to the solution. So in this type of problem, right, let us take the dimension of the column and rows. So row and column is going to be length of matrix and length of matrix, the first row. Once that is done, right, we are going to create a cache. So I can say cache, or I can say give a dp name, whatever it's appropriate. So here I can say def, and let's say I can say max square, or this would be basically a dfs function, right? Here I'm going to pass in my current row and column value. So here, right, if my current row is less than 0, or row is greater than equal to row, or column is less than 0, or column greater than equal to column, then I can say return 0. In else, I can say, now we know, right, it's not out of bounds. So I'm going to say cache, and I'm going to initialize the value, or let's say I can say if r and c not in cache. So in that case, what I can do, I can simply say cache of r comma, or let me say r comma c. Initially I'm going to give a value of 0. Now one more thing to be done, which is to check what is the current value of it. So if matrix of R and C equal to 1. In case it's 0, right? So we have already initialized with 0 values, so no need to do anything. So in that case, I can say cache of R and C is going to be 1 plus, and I have to call the function, so I can say minimum of max square, and here I can pass in R plus 1 and C to get the value on the right, comma max square R and C plus 1 to get the value on the bottom, and again max square R plus 1 and C plus 1. That is the idea. And at last I can say return cache of R and C. Now I can call this function, so I can say max square and I would be starting from 0 0, and at last I can say return, and out of cache I have to find the max value, so dot values, and I can take the maximum of it and I have to multiply it by 2 to return it. Let me run the code. It should work. Yeah, one spelling error. It is throwing one error. Let me check. So after thinking, right, I think there is one mistake I did. Let me create a variable. Let me say right is going to be max square, and here it would be R plus 1 and C. Then it would be down, which is going to be max square. It would be R and C plus 1, and let's say left diagonal is going to be max square R plus 1 and C plus 1. Let me just take these spelling errors and let me calculate the values out here. Let me say right, down and left diagonal, and let me run the code. Okay, one more thing I forgot, which is right, instead of multiple it should be to the power of 2. Let me run it again. So if the value is 3, right, so it's a 3 cross 3 matrix, so it would be 9. So that's the idea. Let me submit the code. As you could see, it got submitted, and it's a pretty efficient solution. So if you look into the time complexity, it would be big O of m, and the space complexity would again be big O of n. So it's a kind of a linear time solution. That's all for this video. See you in the next one.